My name is Nur Shamimi binti Norsha. My metric number is DF2510011. So today I would like to present about my part, which is introduction and problem statement. So firstly is first order differential equation known as dy per dx equal f xy of two variables x and y with its function which define of a region in the xy plane. So it only has first derivative, which is dy per dx, so that the equation is of the first order and no higher order derivative exists. For the second order differential equation, defined as a differential equation that includes a function and its second order derivative and no other higher order derivative of the function that can appear in the equation. So this project switched from the first order to second order differential equation or equation with a second but not in a higher derivative. At any given time, the particle position is xt and its velocity and acceleration are given by the derivative dx per dt and d2x per dt2. So there are no general laws for the position of velocity of the particles, but there is a very important law for its acceleration. So Newton's second law tells us that mass times acceleration equal to force, which implies that m d2x and dt2 equal to f, which is f is the force that acting on the particles. So the force need to be constant and may vary with the position x of the velocity dx per dt of the particles. Depending on the precise detail, we can get a second order differential equation for x as a function of t. And the solution of this equation can tell us how the particle can move. Okay, next is problem statement. So in this project, we civil engineering students need to create our own problem in civil engineering areas. So nowadays, accidents often happen due to drivers who are less attentive and not prudent while driving. A driver who accelerates and stops his vehicle drastically cannot clearly estimate the position of his vehicle. This situation often occurs on the road, especially when facing street roads and red traffic lights. Vehicles such as cars tend to stop their vehicles drastically even in high-speed driving conditions. Therefore, the purpose of this project is to find out what happened to the car position and its velocity in the next 10 seconds to the vehicle if driving at a uniform speed, even if the car has to be stopped drastically.
Okay, Assalamualaikum. My name is Nurul Aisha Mufazazar and my matrix number is DF2100075. Here I will explain the methodology of our project. So as we can see in this slide, we use FILA table as our guidance on solving the problem. So FILA is planned as facts, idea, learning issues, and action. So the process of the FILA table is the first one, we identify the facts about the problem. And second, list all the information about the problem. And third, learn the issues and analyze the solution. And lastly is get all the sources from internet, book and journal as a reference to solve the problem. Next, we take a look on our FILA table. So the first facts about our problem is the car with initial position 100 meter and velocity 4 meter per second at straight road. The second one is the position of the car if time taken is 10 seconds. The third one is the velocity of the car if time taken is 10 seconds. So the ideas from the facts is the data will be used to develop the first differential, determine the constant by using initial condition, and develop first and second integration. So the issue we learn from the idea is how to develop first differential, constant value, first integration and second integration. And lastly, the action we take is find reference about the differentiation and integral equation from book 3, and then use y0 equal to 100 and differentiate equation 150 equal to 4, and then use the first integration yt equal to integral 3t plus c dt equal to 3 per 2 t the power of 2 and plus ct plus d. And lastly is use the second integration yt equal to integral 3 dt equal to 3t plus c. We identify that the equation methods that we have to use in our problem is three: differential equation, homogeneous equation, and integral equation.
Now to calculation. Oh, before that, I am Narisa binti Ahmad. So, okay, calculation. So based on the equation, we need to find the car position. Let me just read the equation. So at the straight road, a car has initial position at 100 meter with initial velocity of 4 meter per second. The car travels with constant acceleration a equals to 3 for the next 10 seconds. Estimate the car position and the velocity for the next 10 seconds. So based on the question given, we need to find the car position, which is represent y, and also velocity u at t equals to 10 seconds. There is some information that we can use to solve this question, which is t equals to 0, the initial position, and then the position represent y is 100, u velocity equals to 4, and acceleration 3. Another one is t equals to 10. So shall we moving on to the calculation? Since we're using second ODE method, we need to find two constants. Based on the information given, we find that d in the equation is 100. After we differentiate the first equation, we get that c is equal to 4 by substitute all the information that we get. Since we have two constants now, we can solve the problem by substitute the value of d and c into the first equation. We get the equation of y in bracket t equals to 3 over 2 t squared plus 4t plus 100, and then we can determine the position of car when the time is equal to 10. Just substitute the value of 10 into the equation that we find just now, and we get the position of car when the t equals to 10 is 290 meters. Second one, we need to find the velocity of the car. By using the equation that we have differentiated before, we just need to substitute t equals to 10, and we get the velocity of the car at 10 seconds is 34 meter per second. I guess that's all for the calculation. Thank you so much for listening.
Assalamualaikum. My name is Nur Husnina binti Isa, and I will present about the discussion for our project. When we solve a second order differential equation, we get a general solution containing two arbitrary constants. Generally, the values of two arbitrary constants are undetermined, but it can be found by using additional information provided in the statement. We can consider the differential equation is same to y prime t equal to a, where t is the independent variable and a is a constant. This equation describes the motion of the vehicle with a constant acceleration a. In this case, our a is 3. Then our differential equation becomes y prime t equal to 3. This equation can be solved by integrating both sides 2 times. The first integration is yt equal to integral 3 dt equal to 3t plus c. A second integration will be integral 3t plus c dt equal to 3 over 2 t power of 2 plus ct plus d, where c and d are the two arbitrary constants. For equation 1, we can determine velocity dy per dt of the motion based on the given t value, while equation 2 gives the value of position. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alisha Fariha binti Kamar Zaman. I want to conclude our project after solving the problem using physics and mathematics application in mathematical engineering, that we will find out where the car travels and the velocity of the car in 10 seconds on a straight road. This problem is solved using the second order differential equation method. And what can be concluded here is that the speed of the car is reasonable for the next 10 seconds with constant acceleration is 3. However, car drivers are advised to be careful and not to drive above the prescribed speed limit in order to reduce road accidents. As civil engineering students, we should use what we have learned and use the knowledge we have to solve all the problems because it all relates to the application of mathematics and science in real life. That's all, thank you.